everybody. I wanted to go ahead and revisit balancing chemical equations, also known as Chem Activity 27, or that's where you're going to find it in your activity book. I wanted to go ahead and work through two practice problems and how to balance them. So the first equation that I'm going to balance is a reaction between Fe, or iron, H2SO4, which is sulfuric acid. That is going to produce Fe2, in parentheses, SO4, 3 plus H2. Anytime that you're ever asked to balance a chemical reaction, you're going to be presented with something like this. This is an unbalanced chemical reaction. One of the most important things is that these are all the molecules that are both the reactants on this side, reactants, and your products. So whenever I say these are all the molecules, one of the things that I'm really kind of driving at is any subscripts here, like the 2 and the 4 for sulfuric acid, you're never going to change those. All that you're going to change is you're going to put a coefficient in front of all of these different molecules. Sometimes you won't put a coefficient, sometimes you'll leave it basically as 1, but you're going to manipulate coefficients so that you have the same, your goal is same number of atoms on products, products and reactants side. And whenever I say same number of atoms, I mean of each element. So for instance, you'll have the same number of iron atoms on both the reactants and the product side. So let's actually go ahead and get into balancing this chemical reaction. Now, what I want to draw your attention to first, and I'm going to erase some things, is I want to draw your attention to what are the different atoms that you have here. And what's important to do, and what I always like to do, is I like to write out the identity of all of the atoms that I'm balancing. Iron, hydrogen, sulfur, oxygen. On the reactant side, iron, hydrogen, sulfur, and oxygen on the product side. So the first thing that I want to do is go after something like, well, basically something that's not hydrogen. I'm going to go after iron. I want to balance iron before I balance anything else. So what I'm going to do is I'm going to see on my reactant side, I have 1 iron, and on my product side, I have this molecule right here, which is iron 3 sulfate. So that, how many iron atoms do I have within that molecule? I've got 2. So if I have 1 iron on my reactant side, 2 on my product side, well, this is a pretty straightforward. Put a 2 coefficient in front of the iron atom there. Now I have 2 iron on my reactant side, 2 iron on my product side. Okay, so I'm going to go ahead and write 2 and 2. Okay, what I like to do is I always like to keep track of kind of the steps that I'm taking. So I've added my first coefficient. What I want to do now is go ahead and take stock of everything else that is in my molecule. So I have, or I'm sorry, what else is in my products and my reactants? I have 2 hydrogen, I have 1 sulfur, and 4 oxygen. On my product side, I have how many hydrogen? I have 2 hydrogen in the form of H2, I have 3 sulfur, and since I have this 3 coefficient, or subscript, I'm sorry, this 3 subscript outside of the parentheses, that 3 is going to multiply, or yeah, I'm going to multiply any of the subscripts that are within that parentheses by 3, which is where I ended up with 3 for sulfur. So what does that mean for oxygen? I've got 12. Okay, so I balanced my iron, my hydrogens are already balanced. What's not balanced is my sulfur. Okay, so whenever I look at this, whenever you look at this, what I want you to see is SO4. That is a polyatomic ion. It is SO4 on the reactant side, and there is SO4 on the product side. So that's kind of going to remain intact. That's not going to react with anything in particular. It's not going to break down or anything like that. So That's something that you can kind of appreciate. Now, what does that mean in terms of the coefficient? What I want to do is I want to put my 3 coefficient in front of H2SO4. So what does that mean? I'm going to go ahead and draw my next kind of the addition of my next my next coefficient. How does that impact my irons? It doesn't. How does it impact my hydrogens? Well, it does impact my hydrogens. I've got H2 and there are 3 of those. So hydrogens, I have a grand total of 6. Sulfurs, well, I've got 3 of those. Oxygens, I've got 12 of those. Okay, now let's go over to the other side. Did my addition of that 3 coefficient change anything on the product side? No, it didn't. So iron remains the same, hydrogen remains the same, and sulfur remains the same, oxygen remains the same. Okay, so now what I need to do, after I've added the second coefficient, I can see that, well, I have an imbalance, and my imbalance is in my hydrogens. Okay, everything else is actually squared away, it's ready to go. So what does that mean? Well, if I look on my product side, one of my products is H2. So if I change my coefficient in front of there, that's going to change, and that's the only place where I'm going to see my hydrogen. So that's going to change my hydrogen count. Now, if I have 6 hydrogen on my reactant side, I need 6 hydrogen on my product side. So an easy way of doing that is adding a coefficient of 3. All right, so does that do the trick? Does that solve everything? Okay. Iron remains the same, hydrogens I'm at 6, sulfur I'm at 3, oxygen I'm at 12. Iron on my reactant side I'm at 2, hydrogen I'm at 6, sulfur I'm at 3, oxygen I'm at 12. Okay, so this equation is now balanced. Now, what we can say about this is that ultimately 2 molecules of iron will react with 3, sorry, I'm just erasing this. 2 molecules of iron will react with 3 molecules of H2SO4 to produce 1 molecule of Fe2SO4 and 3 molecules of H2. Okay, I hope that was helpful. We're going to go ahead and balance one more chemical reaction on the next page. So this next chemical reaction that we're going to balance is one that's known as a combustion reaction. And that reaction is going to consist of a hydrocarbon, CH4, added to O2, and this arrow is going to indicate that it's producing, or it yields, CO2 plus H2O. Okay, now what do I need to do to balance this? Well, I want to go ahead and look at all my atoms. I've got carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. How many carbon do I have on my reactant side? How many carbon do I have on my product side? Well, there's 1 carbon there in CH4, and then on my product side, the only place that carbon is found is in CO2. There's only 1 of them there. Now, hydrogen. Hydrogen as a reactant is only found in the molecule CH4. It's not found in O2. So I have 4 H there. Okay, on my product side, H2O is one of my products. That's the only place where I'm going to find hydrogen. And what that means is I've got 2 hydrogen. Okay, on the reactant side, for my last atom that I need to balance, that is oxygen. I have 2 oxygen atoms. On my product side, I have 2 oxygens in the CO2 and 1 oxygen in the H2O. So here's a little bit of a tricky thing. We have 3 oxygen on my product side. So what this means is that I've got an imbalance. I've got an odd number of an odd number of oxygen on the product side and even number on the reactant side. So how do I actually navigate this? I don't have to worry about my carbons or hydrogens at this point. All that I really want to focus on are my oxygens. Okay, so where could I put a coefficient? Well, actually, on second thought, let's go ahead and look at our hydrogens, because that seems fairly simple. We have 2 hydrogens on our product side, 4 on our reactant side. So if I put a 2 coefficient in front of my hydrogens, what's that going to do? Well, that's going to change my numbers a little bit. Let's look at that. The addition of that 2 coefficient, well, on my reactant side, nothing changes. 1, 4, 2. On my product side, did that change? Did the presence of this 2 coefficient in front of H2O, did that impact our carbon numbers? No, it didn't. Did it impact our hydrogen numbers? You betcha. We're up to 4 hydrogen. Now, with respect to our oxygen, well, we have 2 oxygen in the CO2 molecule, and now that we have 2 H2Os, we have 2 oxygen there. So our grand total of oxygen on our product side is 4. Oh, what we did whenever we added that 2 was we were able to change our we were able to change our number of oxygen from an odd number to an even number. Okay, so now what does that mean? Well, carbons are the same on the reactants and the product side. Hydrogen are the same on the reactants and the product side. Oxygen are different, but we're able to avoid the problem that we ran into previously. Now our oxygen, we've got 2 of them. So what do we need to do? We need to up that to 4. Oxygen is only found in O2, so we can just throw a 2 out in front of there. How does that impact our oxygen numbers? Now we have 4 oxygen atoms. We still have 4 hydrogens, and we still have 1 carbon. So is everything balanced? Absolutely. And we were able to balance this fairly simply, and we only included 2 coefficients. So what this tells us is that 1 molecule of CH4 will react with 2 molecules of O2 to produce 1 molecule of CO2 and 2 molecules of H2O. You could also look at this as 1 mole CH4 reacts with 2 moles of O2. And I'm just going to go ahead and write perfectly. So that's a perfect minimum ratio. Now, this mixture is going to will produce 1 mole CO2 and 2 moles of H2O. All right, well, I hope this was helpful. And balancing chemical reactions really doesn't have to be very difficult, especially whenever we're not dealing with a very complicated reaction. So these 2 examples were pretty simple and straightforward. All right, well, thank you very much for watching.